Kelvin Celsius Fahrenheit. What's the difference? Today we're going to be talking about the differences between Celsius, Fahrenheit, Kelvin, and why those differences are important. You might have grown up with Celsius or Fahrenheit, depending on where you grew up, and being more comfortable with one or the other. But what we're going to look at today is how each of them came about and why it's important in science to have the Kelvin scale. So, looking at the Celsius scale, when it was first developed, they used 0 degrees Celsius as the freezing point of water, 100 degrees Celsius as the boiling point of water, and set their scale from there. In 1724, the Fahrenheit scale was defined as having the 0 be the freezing point or equilibrium point of a mixture of ice, water, and ammonium chloride. Basically, a specific salt water, and when it would freeze. And then he set the high end as 96, which was thought to be the average human body temperature. It was a little bit later he realized that it would be more standard to put the Fahrenheit scale on the boiling point and freezing point of water. So he set 32 was right by where water froze, so he set it as 32, and 212 degrees Fahrenheit was where water boiled. So he set that as the scale and went forward from there. 50 years later, there were scientists using the Celsius scale, and while they were looking at the gas laws, they realized that if you chart the volume of an ideal gas versus the temperature in Celsius, so you have Celsius as your X, volume as your Y. If you chart that, then you end up with the volume going and hitting somewhere here. Right? And then they tried another ideal gas, and they got it going there. And they tried another ideal gas and got it going there. They all kept having a 0 volume come up at the exact same point. Negative 273 degrees Celsius. So in 1848, Lord Kelvin proposed using a scale where this was 0. So instead of having negatives in there, you'd set your 0 as the lowest temperature that you could get something. Making the scale then look like this. And one reason this is great and useful is because when we look at temperature in thermodynamics, temperature is the average kinetic energy of all the molecules in the material you're dealing with. So if you cool it down and cool it down, that means all the particles inside that material are moving less and less and less. And there comes a point where you can't have them move any less. And that's the point of absolute 0, where it's the theoretical point where there would be absolutely no movement of any particles in the substance. Unfortunately, we can't actually get something to absolute 0. The lowest that we've actually had scientists get something is 38 picokelvin. So that's 0.0000000000038 Kelvin. That's really cold. But we're never going to be able to get to 0 Kelvin because that would violate the Heisenberg uncertainty principle, because we would be able to know the position and momentum of particles at the same time. So we're never going to be able to actually get there. But we can get really close, apparently. But one of the great things about Kelvin is that if you double the temperature in Kelvin, you've doubled the internal kinetic energy, or the internal energy. Whereas if you double Celsius, you don't necessarily double the energy. When you double 0, that's still 0, right? When you double 20, the 20 in Celsius would be about here. And if we double that to 40, that would only put it about here. Right? Because 20 plus 273, you're looking at 293. Doubling it would be 40. Adding 273, we're only looking at 313. So it's not that much of a difference on the Kelvin scale, even though it is doubling the temperature on the Celsius scale. The Kelvin scale used to be called the absolute Celsius. A change in temperature of 1 Kelvin is the same as 1 degree Celsius change. So the size of each degree is the exact same because they just shifted where the 0 is, going from Celsius to Kelvin. And, interesting to note, Fahrenheit has its own absolute Fahrenheit scale. It's called the Rankine temperature scale, where, yes, 0 is still absolute 0, which is at negative 459.67 degrees Fahrenheit. But since most of the world uses Celsius, you're not going to see that one very often. But it is there. So there we have it. A quick breakdown of the temperature scales. As always, remember to like and subscribe. And remember, as you go through life, keep questioning till you have the answer.